Assalamu alaikum. In this video, we will be talking about photoelectric effect and the wave-particle duality. We have quite a few evidences to support the wave nature of electromagnetic radiation, which includes Young's double-slit experiment and diffraction grating experiment. But here, we're going to talk about the experiment which suggests the particle nature of electromagnetic radiation, and that is photoelectric effect. A photoelectric effect is basically the random emission of electrons from the metal surface when electromagnetic radiation falls onto it. The properties exhibited by the photoelectric effect cannot be very well explained by using the wave theory. Let's talk about the properties first. It is an instantaneous process. That is, there is no delay between illumination and emission. That means when electromagnetic radiation falls onto the metal surface, that very moment the electron emission would start. Now, that would not have happened if electromagnetic radiation was exhibiting a wave nature, because as continuous stream of energy is being absorbed by electron, obviously there should have been a little time delay for electron to absorb the required amount of energy and hence emit out from the surface, which is not what is happening here. So Einstein suggested that electromagnetic radiation in some cases exhibits a particle nature. That is, it has a wave-particle duality. He said that electromagnetic radiation travels in the form of bundles of energy. To each bundle, he named photon, and the energy of each photon is calculated by E equals hf. And he explained the first property by saying that since it's a single photon, single electron interaction, so it has to be an instantaneous process, and hence there is no time delay between the elimination of electromagnetic radiation and emission of photoelectrons. The second property is that no emission takes place if frequency is below a certain minimum value called threshold frequency, which is different for different metals. Now, if we follow the wave theory here, then this particular property can also not be very well explained. If there is a minimum threshold frequency, then why is that so? As electromagnetic radiation falls onto the metal surface and electrons absorb the sufficient amount of energy and they emit out, then that should occur for even a frequency below the threshold frequency. Or if it is a matter of rate of arrival of energy, then obviously the rate of arrival of energy can be increased by increasing the intensity or hence the amplitude of the wave. But that is not effective in this case. Einstein explained it by saying that since energy of each photon is E equals hf, so below threshold frequency, each photon does not carry enough energy, which he called as a work function energy, to remove the electron from the metal lattice. Third property is that above threshold frequency, rate of emission is directly proportional to intensity. That is, more emissions would occur, but the maximum energy of photoelectrons remains same. So if you increase the intensity, the number of emitted electrons would increase, which was not happening below the threshold frequency. And also, if you are increasing the intensity, that means you're delivering more energy, but still the electrons which are emitted out, they carry the same maximum kinetic energy. This was explained again by Einstein by saying that since energy of each photon is E equals hf, if I'm not changing the frequency and increasing the intensity, that means that I'm sending out same energy photons, but more number of photons. And since I'm sending out same energy photons, so electron receives the same amount of energy and the electron that emits out would be carrying the same amount of maximum kinetic energy. But since I'm increasing the intensity with same frequency, so that means the number of photons should increase, and hence the number of photoelectrons which are emitted out would also increase. Next property is that if I keep the intensity constant and I increase the frequency, the rate of emission of electrons decrease and more energetic photoelectrons are being emitted out. I keep the intensity constant, I increase the frequency. When I increase the frequency, more energetic photoelectrons, but lesser number of photoelectrons are being emitted out. This cannot be explained by the classical wave theory. Einstein explained this by saying that if you increase the frequency, that means the energy of each photon should increase. And if energy of each photon is increasing, so that means the energy of each photoelectron should also increase. And as energy of each photoelectron is increasing, so of course electrons are going to come out more energetically. Since we are keeping the intensity constant and increasing the frequency, so that means if I have to deliver same amount of energy with more energetic photons, so the rate of arrival of photons should decrease. And since the number of photons arriving at the surface are decreasing, and hence the number of photoelectrons which would be emitted from the surface would also be lesser. Finally, the last property, which is photoelectrons have range of kinetic energy. So that means as photoelectrons are emitted out of the surface, not all electrons carry the same amount of energy. This happens because these photon electron interactions are taking place everywhere in the metal structure, not only at the surface. So the electrons which are coming out from deeper inside the surface would lose more energy due to collisions with atoms, and hence these electrons would be leaving the surface less energetically. The electrons which are emitted from the surface would carry the most kinetic energy, which is called the maximum kinetic energy of photoelectrons.